In this video, I'm using a Redtech 12A AC recharge kit to fix my Mazda 3 air conditioner problem. I had the same problem with my Nissan 1 year ago. Perhaps when vehicles turn 10 years old, they lose the refrigerant. You can see the AC compressor down there, and basically that black end piece is not spinning when the vehicle is on and the AC is on, which indicates that the clutch is not engaging and therefore there's no coolant circulating. And the reason for that is that there's just no coolant in the system, so it doesn't kick on. I would recommend checking the fuses and relays before you go and buy the kits. The kits are a little bit expensive. Here in Canada, you have to use this 12A kit. They actually don't let you buy the type of refrigerant that comes with the vehicle. And I checked the relays just by removing the horn relay. Obviously it works, and swapping it, and it made no change. And then there's a fuse as well. So you can pull that fuse and make sure it's good. And in my case, both the relays and the fuses seemed fine. So I kind of knew this was maybe going to be the case right away. But I am going to just take a screwdriver and poke down the valve on the low side, and absolutely nothing happens. I've already done this, that's why I've got the kit in hand. And even on the high side, absolutely nothing comes out. There's no hiss. There's no pressure whatsoever in this system. So although the 12A and 134 are compatible refrigerants, apparently, you are not allowed to mix the refrigerants, at least in Canada. So check with your local laws on this. But since my system has self-evacuated, I'm not really mixing the two different types of refrigerants here. So the first thing I'm going to do is put the adapter onto the low side. If you have an older vehicle, these kits also come with a different adapter. If you're in the States, I believe you can still buy 134A, but the process I think is generally the same. The first can I'm putting in is the leak stop. I screwed the can onto the gauge, and then there's a little T at the top, and basically when you screw down the little T there, it will puncture the top of the can and allow the refrigerant out. I find you do have to back the needle off a little bit, like turn the T to the left, and that helps the refrigerant come out of the can. So once the can's punctured, the pressure goes up to about 70 psi, and I hold the can upside down for a while, shake it around a little bit, just to try and make sure that I got all of the refrigerant out. After that, I turn the T-handle clockwise all the way down to stop the refrigerant flow, remove the system from the low side port, and remove that can. And then I need to figure out how much just straight 12A refrigerant I need to put in the system to bring it up to its full charge. You do have to do some math. You can see on the low side, you can see the minimum amount of refrigerant is 0.455 kilos and the max is 0.505 kilos for this system. And then on the cans, it's going to tell you what the equivalent is for the 134A. So refrigerant 134A, and you can see on the stop leak can that I put in first that it is only equivalent to 57 grams, and then this can, the entire can, is equivalent to 454. However, you do lose a little bit of the refrigerant when you put valves on and off, and there's a little bit that remains in the can because the pressure will maintain some of the refrigerant in the cans. So I think I'm good. I should be right in the pocket of the right amount of refrigerant in the lines. So now with the vehicle off, I'll put the adapter back on again, the R12A screwed on, and then I will screw the needle down to puncture the can and then back it off once again. And you can see that the pressure gauge jumps up into that 50, 60 kind of PSI range. And then once you go in and turn the vehicle on, make sure that the AC is on max AC, just to ensure that the actual compressor is going to run. You can see that the pressure on the low side drops down significantly, and it's going to end up around the 30 to 40 PSI range on the low side. They do make better systems that actually connect to both the high side and the low side, and that'll give you a better pressure readout. These basic recharge kits just come with the low side adapter, I believe, in most cases. And like I said, I did do the Nissan last year with the exact same system for the exact same problem, and it's still going strong. So after 1 year, just the two cans did the trick, and hopefully this is the same way. Maybe just over time vehicles lose small amounts of their refrigerant and need to be refilled, and maybe 10 years is that sweet spot when they die. I don't know. Anyway, take the can off. And then I'll go use my AccuChef again, which I use with the Nissan, and this is for cooking turkeys and stuff, but it works well for testing the vent temperature. So you can see I started at about 76 Fahrenheit. And obviously I got the AC running full blast, and you can see it coming down pretty fast. With the air conditioner running on full, I find that it sits just below 50 Fahrenheit. So you can see that it's coming into that pocket right about now. And then in Celsius, that's about 9, somewhere between 8 and 9 Celsius. And that's with the AC on max. If you actually slow the fan speed, the air coming out actually becomes cooler. Obviously, it's not as much air that the system's trying to cool, so you could get the temperature down a little bit lower. So there it is with the AC blowing at just setting number 1. So 43 Fahrenheit or 6 Celsius. So overall, it's working, and hopefully this charge holds as long as the Nissans did. Anyway, thanks for checking out my video. Don't forget to like and subscribe.